Hello. We are going to consider a log linear model and log model in this video. So log linear model is a model where the log is taken only on the outcome variable, y, but x is used itself. So then, remember now, basically beta 1, the interpretation of beta 1 is that when x increases by 1 unit, log y increases by beta 1 unit. But remember, beta 1 increase in log y means the original y increased by 100 times beta 1%, right? So I will skip this. It's not that intuitive. So just keep that in mind. Increase like beta 1 increase in log of x, log of y is equivalent to 100 times beta 1% increase in y, in original y, right? So remember, 1 unit in increase in x means beta 1 increase in log of y means 100 times beta 1% increase in y. So this beta 1 is in absolute unit and it is percentage unit. So the percentage change is different. So therefore, from now on, the change in y is interpreted in terms of percentage concept. So 100 times percentage. So then the problem is this unit also affects the error term. Error term, say for example, when the error term increases by 1, that means that means that means the log n increases by 1. That means y increases by 100%. Log n increased by 1 means y increases by 100%. So the error term now captures the percentage change, not the absolute y change. And for another example, say the standard error of the regression is estimated to be 0.2, which means the standard error is 20% change in y. So 0.2 is the standard error of log of y, which can be interpreted as 20% of y. So like converting between y and log y is applied to in the same way to the error term, and it's standard error, right? So it's a proportional deviations. The deviations, standard errors, are interpreted as percentage of y. So always keep this in mind. So you need to do it by yourself. Think carefully what we are doing and how we convert log of y into y and vice versa. Once you understand it, its interpretation should be straightforward. And the next model is log model. So log is, in the end, it is easier because we explain what's going on, and as a result, I will leave it to your exercise. So you may try what so beta 1 is can be interpreted in that when log x increases by 1 unit, log of y increases by beta 1 unit. Beta 1 unit, right? So 1 unit increase in log of x is equivalent to 0.01% increase. Excuse me, 100% increase, and then 100% increase in x implies 100 times beta 1% increase in y. So in the end, 100 is multiplied on both sides, so they canceled out. So as a result, it's simple. The interpretation is simple. 1% increase in 1% change in x is associated with beta 1% increase in y. So log specification is has the simplest interpretation, and this percent by percent change is the definition of elasticity, like demand elasticity of price or supply elasticity of price. I hope you remember what it means. So in microeconomics, you learned the elasticity, which was defined as percentage change in demand or supply divided by the percentage change in price. So same thing here. So this is exactly the regression equation that estimates the elasticity of demand or supply. So elasticity is estimated exactly by this log-log model. And now let's apply these two ideas, log linear model and log-log model, to our example, test score and income. So implementation is simple. Just define a new random variable as log of test score and another variable as log of income. Then you may just put the correct variable, random variable, into the command. Then you can obtain the regression result like this. In this case, the coefficient is 0.0554, which means when your income increases by 1%, then test score increases by 0.05%. 0.05%, right? So interpretation is easier. You don't need to worry too much about these numbers. And exactly this is what it implies. And so then why does it make sense? Then it depends on whether you. So I explained why we need to take log on income. Then maybe that may be similar to test score. So 1 point increase from 1 point increase may be different at different groups, like low score group or high score group. 1%, 1 point difference could be different. So maybe percentage different may be more appropriate to evaluate the test score change. So 1% change and 1% change, is that more equivalent? Or say certain points, like 10 points, is that more equivalent? It's uncertain. It's hard to think about this. Say, suppose that your GPA is 2.0. So consider there are two students. The first student has a GPA of, say, 1.5, and the other student has a GPA of 3.5. Say then I will ask them to increase their GPA by 0.5 points. Then is that who has bigger difficulty in that? Is it similarly comparable or not? Or I may ask them to increase their GPA by 10%. So I'm asking the guy with GPA 1.5 to increase his GPA by 0.15, and the other guy who has a GPA of 3.5 to increase the GPA by 0.35 points. Is that like comparable? I don't know. I'm not so sure. I don't have good intuition which is better. Then you may just compare the results. So we have two. It's about log linear regression and log regression model. So when you take log of test score, now vertical axis is log, and the difference is whether you take log on income or not. So when you compare them, linear model, log linear model is worse fit than log model. I think log model is doing much better job. So when you compare these two, log model looks like doing better than log linear model, but it does not show the result how it compares between log and linear log model. I'm curious about that, but I didn't do that. but we may compare them like this. You may just have two scatter plots and see which fits better. And then if one fits better than the other, then you may choose the better one. So summary. There are three cases, linear log, log linear, log log. And the interpretation should be careful. The key idea is you should be like 1 unit increase in log is equivalent to 100% increase in the underlying variable. So 1 unit increase in log of x means doubling x, 100% increase in x. So just keep that in mind and apply that conversion to any model you have. So then it will be easier. So you don't need to memorize that. Memorizing this is very dangerous because it's very confusing. So but implementation wise, it's super simple. So on Stata, you just need to define a new random variable, and everything else is the same. You just need to interpret the result more carefully. That's all. And I am going to skip this chapter, this section. We consider some special model using exponential function. It's I will skip this, but we have an important section later. So in the next video, I will explain interactions between regressors. So it's also very interesting and important. So see you later.